Well, thank you. So, um, so yes, I'm here to talk about hacking air traffic control systems. Um, like most things, it started with liquor, so had to integrate that into the title. Yes, my name is Brad Haines by day. RenderMan's the nickname. That's where all the street cred is. So who am I? I'm a man of many hats. Normally a fedora, but today is the old pilot's hat. Pen tester for ATP Financial, and just a disclosure, I have anything I talk about here has absolutely nothing to do with the bank, so it has nothing to do with my employer. This is what I do on the side for fun. Written some books, been all over the world doing trainings, wireless physical stuff. RenderLab.net's my website, also a member of Nomad Mobile Research, co-founder of the Church of Wi-Fi. I am the Pope of the Church of Wi-Fi. Everyone should have their own religion, it's fun. Known as the notorious Canadian hacker, basically because I'm a very proud Canadian. I'm very proud to be here finally at a HackerCon in Canada. Usually I have to go elsewhere to see people of my same disposition, not necessarily haircut, but I'm very proud to be here and support Canadian hackers. So, been to DEF CON since 1999. Speaking like for the last 8 years there, I'm an old timer, but white hat by trade, black hat by fashion. I love a SpongeBob. Do not actually try any of this stuff you see here at home. Commercial airliners in the air, people, millions of dollars worth of equipment and cargo, you can get in some real trouble really, really quickly. So please do not, actually try any of this, but share this information with those that have an ability to make things safer, to get things safer. There's no knowledge is bad. There's some things you could unsee, but that's a separate issue. But also think about how this was allowed to happen. This major thing. I mean, air travel is something we all take for granted nowadays. And when you're going to see, your head's going to hit the table saying, what the hell were they thinking when they did this? And, I fly a lot, so part of it's self-preservation. I want to make air travel safer because I like my ass, and I want it to get home in one piece. And in case you needed to know, here are the relevant sections of the Criminal Code and Aeronautics Act. Basically, screwing with anything dealing with air traffic, up to life. So don't do it. It's a weird presentation in that I want to be wrong. I am doing this presentation. I can't actually prove any of it because legal, ethical, classified stuff. But I have a lot of supporting documentation, in fact, that is public. I want to prove to myself that air traffic control is safe. Doing all the research I have, I've failed at that. I've yet to prove to myself that it's safe. So I'm looking at the communities to help me with this, prove me wrong. To anyone that's, with the federal government or has contacts with NAV Canada or Transport Canada or anything like that, to push them to disclose, some of these things, because I don't think any of us like the idea of not knowing if something's secure or not, and not having it demonstrably proven. I'm not a pilot, air traffic controller, never, if you ever see me behind the flight yoke of a plane, run. It's not a good place for me to be, usually because I'm raiding the bar cart. I may get some details or acronyms wrong, but, correct me. I'm full of mea culpas. I may run a bit long, so we'll see. Theo and Iftak, if I run long, I owe him a beer. That's not a bad thing that I can't prove any of this. This is the 5th version of the talk, and in about 3 years, and I'm still asking questions because I haven't gotten good answers. NAV Canada and everyone still have not responded to any satisfaction. Usually it's just a press release that says, trust us. Well, what, evidence, help. You've got to fill me in on some of these details here. Once reached out to NAV Canada and sent their press guys an email saying, well, you say this is impossible. Can you actually state that this is, not something we need to worry about? Next thing I know is the media guy that I had emailed is checking my LinkedIn and sees, the website and everything goes, and it's like, never heard from him again. Did not want to touch that. The logic and methods here, you can apply to any large system and just look for systemic failures in security. This is just one that we all happen to, a lot of us had to fly here, so lucky of those who could actually drive. We need to get beyond the, vulnerability, exploit, fix cycle. Build systems from the ground up with security in mind. There's a massive disconnect in a lot of industries. You look at SCADA stuff that nowadays is just a sieve in terms of vulnerabilities and holes, that they never built it with security in mind. They were looking at it from a functional standpoint. Same thing with air traffic control. I am providing evidence for everyone to, go through, check my facts. I try to link to as many documents as I can. I'm going to make available shortly after this a zip file of like all the stuff I've collected, that you guys can go through it too. Like I said, prove me wrong. If you're in industry, please prove me wrong. So how I got into all this stuff was with an app. Originally on an iPhone, now they also have it on my Androids. Plane Finder AR. It's kind of a neat program. You take your phone, it looks through the camera, does an augmented reality of any planes that are in the sky, shows you the flight number, where it's going, speed, all that stuff. Kind of a cool thing. At the time, Homeland Security was kind of freaking out about that, and so it's like, okay, I have to have it then. You basically have your GPS location, the direction you're facing, quick web lookup, and kind of neat, pretty basic stuff. That led me to sites like planefinder.net, Flight Radar, Flight Virtual, that aggregate data from all over the planet, of flights all over the planet, and have nice Google Maps of all the air traffic. A lot of this is provided by users on the ground. Some sites augment with FAA and NAV Canada provided data, but that's generally like delayed by 10 minutes and not quite as accurate. But you can then query for specific tail numbers. You can query for, it's really interesting when you go through the list, you can go by airline and then see, German Army. Click, okay, where's the nothing over Germany. Scroll around, where are you? Where the hell is there a German Army flight over Manitoba? Weird stuff like this that you can, you've got all this information there. You can mine it and find all sorts of neat stuff. They've got automated things where it'll, the app will actually tell you when a plane is squawking code 7700, which is an emergency. And usually you pull it up on the map and you can see, okay, we're going here. Oh, U-turn, problem. A lot of media watches those sort of things, waiting for the next CNN to go all sorts of ape poop on the next crashed plane. It's really neat stuff. I mean, it's something we all take for granted. You can generate really pretty maps. I mean, this is from what, about an hour ago, over Quebec City and Montreal. You can see all the planes in red are user-provided ones. The orange ones are government-provided feeds, so they may not be as accurate. But you get an idea of how much stuff is in the air at one time. And this is one of the lower density areas I've seen. I mean, you look at places like London or New York, it's just nuts. You can also do some really pretty visualizations, and I love this video, because it also shows the, can you see that? Oh. Wait, pause. Is that, nope. Come on. Oop. Ah. There it is. So this was provided by European Air Traffic Control, and they took flight data from a single day and visualized it, and you can see through the day the increase in traffic. I mean, you can see the lanes that actually are the planes are flying over the North Atlantic. Really quite fascinating stuff to watch because you can see, when planes are in holding patterns and where they're over. I mean, it's like some of those visualizations you see of the internet where you see the packet fly across the skies and stuff. But it's this massive network of people and stuff moving around, and it's highly complex and frankly very, very amazing. So, oh crap, didn't. So, found all this stuff. Some sites, the flight radar sites, contain info on how they were collecting this information. There were just some things that are dangerous to tell me. I turned into a dog with a bone. I just ended up, researching this stuff and digging and digging and digging and digging. Ended up pissing off air traffic control authorities worldwide. It's been a hell of a lot of fun. I like pissing people off, what can I say? But before we really get into it, let's get you guys some background here. So I was underemployed for over a year, working as a contractor, and as you know, as a contractor, you spend like 60% of your time trying to find the next job. But at the time, I was also doing a lot of speaking gigs that unfortunately didn't pay a lot, but it was something. And hey, free trips. So I started thinking about airplane tracking. I had this app. It's read this stuff. I'm like, I wonder, how all this works. I wonder if they've actually secured this. If there's any issues here. And when I get bored, like being underemployed and spending a lot of time on my couch, bad things happen. This is why I should always be employed. So air traffic control hasn't changed much since the 70s. I mean, there's been new systems come online and that, but in general, for a long time, it was radar. You're pinging a radar signal off of, flying tin, comes back. That's how you tell where things are. The primary radar basically provides a range and a bearing, how far away it is, at what angle. It doesn't really give you an accurate altitude. There's a thing called secondary radar that actually sends a query to the plane, and the transponder that they always disable in the movies where there's a hijacker and stuff like that. That's essentially what it's querying. It comes back with a 4-digit number and the altitude of the flight. So as provided by the plane. So helps fill in some of the information gaps. This information augments the little smudges on the radar scope, and then provides air traffic control with some more data to work with. The problem is primary and secondary radar only interrogate every few seconds, between 4 and 12. Gives you a very low resolution of altitude as well. It's like you're somewhere within here. Like, well, that could be a few thousand feet, and that's the difference between flying and crashing. The pilots didn't really get a lot of benefit. They couldn't see necessarily where they were. They were basically being guided in by air traffic control and a little bit of instrument. This low resolution meant that you were somewhere within this bubble. You didn't want to get too close to anyone else, so you had to maintain a certain amount of separation between flights. Otherwise, bad things happen. Physics, matter can't occupy other space of other matter. Except on crowded buses. I mean, this is obviously an oversimplification of things. There's so many other systems at play, but this is what you need to know for a quick primer. Basically, up until the last 10 or 15 years, it's been a fairly manual process of air traffic control talking to pilots and vice versa. Instrument flight rules, you probably heard those. Guys flying, they know how fast they're going, how what direction they can, don't even need to see out the windows, kind of thing. Problem is, a lot of those flights are waypoint based. So shortest distance between 2 points is a straight line. Well, they basically have lanes in the sky that you have to go, and work around stuff. That wastes gas. It takes longer. Flights are longer. This was always an annoyance for airlines and such. Air travel is increasing. You can get a cheap flight. Well, not necessarily if you're in Canada, get a cheap flight. Thank you, Air Canada. But in a lot of places you get like Spirit Air or what's the cheap European one, Ryanair, that for like €50 flight all across Europe. Everybody and their dog can now afford. It's not the old Pan Am pictures you see where it's all guys in suits and ladies in nice dresses, and you actually have leg room and something resembling real food. So they're trying to pack more people in, but again, there's only a certain amount of capacity to move people. You get severe weather events. It seems like every Thanksgiving in the U.S. there's like a massive snowstorm at the same time, and it gridlocks everything, and people are sleeping in the airport. There was that completely unpronounceable volcano in Iceland a few years ago that was spewing ash that they had to route around and was causing all sorts of chaos. Something needed to change and hopefully make things safer and more efficient. In the late 90s, the ICAO, International Civil Aviation Organization, who's actually headquartered out of Montreal, is there anyone here actually associated directly with air traffic control or anything? Or, oh, okay. Brave of you actually to put up a hand. They wanted to do more with the same or less equipment. So using similar radio equipment and everything, just software changes if they could. They wanted to modernize the air traffic control system over a span of 20 years, which, when you start looking at how fast technology is moving, is kind of, doesn't make sense to me. So to save costs on equipment, save fuel, airlines are now razor's edge on profits. They want to save time, which also means they increase capacity. You don't have to build extra airports or landing strips because you're able to get more through with the same thing you've got. So the major key feature of this is ADS-B. This is what we're going to be talking about. This is the protocol that is the data source for those plane finder sites and basically the focus of this talk. So what is ADS-B? Automatic Dependent Surveillance Broadcast. Basically, the plane is equipped with GPS, broadcasts its location and other information over a 1090 megahertz link, or if you're in a little Cessna or anything like that, 978 megahertz, once a second to air traffic control. So much, much better resolution of location and altitude than they've ever had before. Aircraft ID, altitude, position, bearing, speed, blah, blah, blah. You can set up a network of ground stations, and they don't take up a lot of space. You can even mount them on like offshore oil platforms, so you can have coverage in areas that previously, you would need a 3-story building size area to mount a rotating radar dish. This is particularly useful over dead zones like that, like mountainous regions over the North Atlantic, Hudson's Bay, Gulf of Mexico. Their initial trials were in Anchorage, in Alaska, where basically to land at the Anchorage airport, you had to fly down the middle of a valley, and it's one of those things of like 30 feet on either side could really make your day suck. So you really needed to know where you were, and if the weather was in any ways inclement, it was a really sphincter tightening kind of flight. Certainty of location also means you can pack flights closer together, which means you can get more through in those lanes in the sky. So there's 2 forms of ADS-B. In and out. Out means out from the aircraft. There's no interrogation needed. The air traffic control doesn't have to do anything to get the information. It doesn't have to send a query or anything like that. It's just broadcast. So it's automatic. Instead of primary and secondary radar, planes use GPS to report. That's dependent. It's dependent on the plane to provide the information. It's omnidirectional, so it's a broadcast. Air traffic control scope is populated with this information, augmented by existing primary radar and other systems, but they're moving to where this is the primary, here's where things are. 1090 megahertz for commercial, like the big 747s and stuff like that. Smaller stuff, 978. There's 2, for some reason they decided, we're going to have 2 separate systems that don't really talk to each other, one for general aviation, one for the commercial stuff. Some genius at that one. Slightly different link formats, so not directly compatible. You have to relay stuff through air traffic control, but effectively they're the same kind of thing. Vulnerabilities for both exist in both. ADSB in means into the aircraft. This is optional. This isn't a requirement, but it allows planes to talk to each other about their location. Traffic awareness, pilots love this because it's a case of, yeah, I mean, they previously had some weather radar and other location sensing stuff, but not this level of resolution, this amount of certainty. For general aviation, they friggin' love it because they've never had any sort of capacity like that before. They can now also get weather information in, provided by air traffic control with this, which is great if you're in a little Cessna that doesn't deal well with tornadoes. Your situational awareness increases, and this is a good thing for pilots. Knowing what the hell is going on around you is a very valuable thing. Problem is, it's expensive. $5,000 to $10,000 for ADSB out. It's one of those things that you can't just. There's no like Rockwell Collins online store for this stuff, so you can't get exact pricing on stuff. But per plane, when you've got hundreds in the fleet, it adds up. If you want ADSB in, it's like $20K. But on the general aviation market, it's actually dropped dramatically because they've got things where it's a little box you stick on the dash of the plane. Grabs its GPS from there, and then over Bluetooth talks to an iPad and uses that as your display. So you're not having a big display you have to install on your dash and everything like that. It's just an iPad. Kind of cool. There's not a lot on the used market, so it's kind of hard to get your hands on, which for guys like me is a problem because I have like zero budget. But as I said, with the general aviation market, it's getting cheap to be able to get into some of this stuff. So, quick diagram. You've got the satellites talking to the planes for their GPS location. ADSB in between the planes, ADSB out to air traffic control. And yeah, again, oversimplified, but fairly basic. There's a thing called multilateration, which I will get into later, but it's usually at this point anybody associated with air traffic is screaming in their head that I haven't mentioned this yet. It's the time difference between the signal receiving stations. So it's the inverse of triangulation, basically. It's supposed to be used to provide correlation for ADSB as a data source. So if a plane says it's here, multilateration should be pretty close to where it's saying it is reporting. Interesting part is there is no indication this is used everywhere, and not a lot of data on how it actually deals with errors between the two data sources. So more on that later. Again, lots of systems in place for data verification, but again, as we know with any system, it's still, there's potential for a lot of flaws. So given all this research, the hacker side of my brain started taking over. It started in, investigate how all this stuff worked. And there's some obvious threats that kind of, jump out at you, and you say, okay, I wonder if they actually took care of this. And you start digging and Googling and try to figure this out. Couldn't get any good answers. Everything I was finding was, trust us. We know what we're doing. How do I know what you're doing? This stuff hasn't been invented before, so we have no basis for comparison. Usually when I hear that from, say a federal agency or anybody like that, they either it means that they hadn't thought of these problems yet, and we're like, oh crap, we're so far down the rabbit hole we can't back out now, or they have thought of it, and again, it's too late to change anything. So I started digging, and like I said, I was just trying to prove to myself that things were safe. Found I wasn't the only one looking. There's been a few others. Ryder Kunkel, Balint Sieber, U.S. Air Force major did it as a paper for his degree. Nick Foster, Adria Costin, Yuko Tesso. There's been a whole bunch of people starting to look into various facets of air traffic security. We've all reached very similar conclusions independently. It's actually kind of funny because Andrea Costin did a talk at the Black Hat immediately preceding DEF CON 20 when I first gave this presentation, doing the exact same thing, and we didn't know about each other. It was quite amusing. that you've got two researchers on opposite sides of the world researching the same thing, reaching the same conclusion at the same time. The scary part is anyone can listen to 1090 megahertz, or 978 if you want general aviation, and you can decode this in real time. It's simple pulse position modulation. There is no data level authentication of the data from the aircraft. Just checksums to make sure that the data wasn't corrupted in transit. There's some correlation with primary radar and through multilateration, but basically ADS-B is unencrypted and unauthenticated. Yeah, unencrypted and unauthenticated, which to a room full of hackers are words that are really, really bad generally. Because you start looking at it and it looks an awful lot like a network packet. You've got headers, checksums, trails, data, middle. Any idiot can get access to air traffic control data, raw. To prove it, I'm running a ground station in Edmonton, which shows just any idiot can do it. I'm uploading this data to those plane finder sites to augment for northern Alberta, because at the time there wasn't very good coverage up there. I have my own air traffic control scope, basically, at home. It's really neat because you can see the common pathways that they take, and you can, when that one flight is coming over and wakes you up first thing in the morning, you can all right, who's that ass? So why does this matter? Why am I concerned? This is being utilized all over the world. This is a worldwide thing. Mandatory in North America in 2020. A lot of other places, it's already mandatory and already fully implemented between 2013 and 2020, depending on various regions and needs. UPS, as part of the test, basically for the FAA, equipped their entire fleet with these things as an initial test. There's planes in the air right now running this stuff for their navigation. It's the inevitable direction. They've spent tens of billions of dollars on this stuff already. They're not going to change it, overnight. I fly a lot, want to get home safely. I'm sure you do too. Except that when you're going to be on that flight, you're going to be thinking about all these threats. First obvious one is eavesdropping. I have access to raw air traffic control data. With this, because you have a known source of data, even if it's a non-cooperative flight that's not necessarily broadcasting its tail number, like, say, Air Force One, or military that has their own encrypted ADS-B thing, because the military decides to do everything else separate from civilian, even then you've got a data source that you can use your own multilateration and figure out where it is. So you could track, I've had friends that have tracked Air Force One that you're not supposed to be able to do that. There's a data mining potential. We know what's in the air, where it is, and if you record it, you've got historical as well, so you can look for patterns. Privacy disclosures for, executives from such and such a company just landed at the city with the headquarters of their main competition. I wonder if somebody's about to be taken over or sold, or what would that do to stock prices? Tracking celebrities, that sort of stuff. It's kind of creepy. Amazing the amount of information you could glean from this in just terms of the creep factor. And frankly, you've got the raw data. Some people could be more imaginative than me as to what they would use it for. So, major one that people think of is injection. Injecting a ghost flight into the system. The interesting part is the documents that I've found that discuss the implementation of ADS-B are basically saying, yeah, we'll correlate it with primary radar, but we'll also turn primary radar off because it's expensive. What? And this is the same document. Now you see why I drink, right? What happens if you were to introduce slight variations in the data? Say, do a broadcast where it's in the same position, and then just slowly diverge the two tracks. What'll happen? I don't know. You could create all sorts of confusion. you start thinking about, again, massive weather delays are already occurring, and now you've jammed things up because air traffic control's going, what the hell is going on here? You look at some of the major travel hubs like Atlanta and New York are always backed up. You look at situations where everybody's trying to go to one place at one time, like London or Sochi for the Olympics. I was watching the flight data in the days leading up to the London Olympics, and it was just like everyone going to there, and it was just nuts. And it's like, if you jam that up, do you imagine the repercussions? It would just be nuts. Could you introduce regular false data that is, after a while just gets ignored? Then you run a real plane down that same path. I don't know. Would it work? There's a lot of documentation I'm finding about multilateration. Nothing making it mandatory, interestingly, or how they are supposed to generate alerts based on an inconsistency in data. So if you're doing a verification, well, how's it telling you this? There's no policy on how it's supposed to generate that. Multilateration is a constant excuse from the FAA and everybody else saying, it's secure. Well, are you sure? Have you tested it? Can I have those reports? They're classified. Yeah, so kind of scary. If we got really creative, we could do multi-point broadcasting and defeat multilateration. Okay, you're going to say, fine, well, we'll just use our antennas and figure out the rough angle that the signals are coming in. Well, I got a truck and a tripod, If I get close enough, I can be at that same angle. And even then, I've already found evidence just this last week that some air traffic control systems may not filter data properly anyways. This European EASA safety bulletin says, when two or more aircraft with the same duplicate ICAO 24-bit address are operating within range of a specific Mode S interrogator, then potentially hazardous situations may arise, which is a nice way of saying weird crap. Aircraft involved may be assessed by the Mode S interrogator as being false or reflected echo and subsequently ignored. These aircraft will not be displayed to air traffic control. In the case of an aircraft whose flight paths cross, the identification labels on this aircraft may inadvertently swap. Place one with the other. On air traffic controller displays, thereby presenting controllers with incorrect information and creating the possibility of misidentification. Performance of ACAS 2, which is a collision avoidance system, could be seriously degraded or even disabled. Eep. So that they already are finding that the system does not deal with weird crap like two of the same addresses crossing, being on the scope, or paths crossing. It doesn't have the resolution to figure out, okay, which went in here, and did they just do a right-hand turn or what? Already a little bit of evidence that this actually happens fairly regularly. I was sent this anonymously. It's a little tricky to see, but you can see that on some of the paths there, you'd see where they intersect, and there's angles in there that are impossible for a flight. They've got measurements on the scale there for figuring out what the turn radius was for this flight, and it's like, yeah, not happening. Look at the one on the left there, you can see it made almost I don't know, what is it, more than a 90-degree turn. So weird crap is showing up, and again, this is coming from public sources where the FAA is providing the data that's coming out of the air traffic control scopes. Another obvious threat, jamming, right? It happens. You have a stronger signal that stomps all over the other one. It could be detected fairly easily. Hey, look, all our stuff just got screwed up. Could be direction found quite easily. But do airports have the equipment to do that quickly? Could I be sitting there for 6 hours while they're on the phone to the FCC or now Canada or Industry Canada saying, hey, we've got this weird thing, we need you to find it. like I said, it could be one of those things you could flip it on for 10 minutes in your car, be gone, shortly after. What if you did this at multiple sites? Like pick all the major travel hubs in the United States. What about around the Sochi Olympics, when everybody's already on heightened awareness and they got surface-to-air missiles and everything, and guys with itchy trigger fingers being fed vodka? We already have situations where there's a single point of failure, where you look at just late September, there was that nutter that tried to kill himself and also set the fiber optic lines for the basically most of the Midwest air traffic control and knocked it out. It took him a week to fix that. And the disruptions show that just one site going down can cause massive delays and pain and everything else. Try doing it at multiple sites. See what happens. Already there's problems. Simple frequency congestion. You can't pack too many planes in the area because there's no contention protocol. TCP/IP, old, clear to send, clear to receive, that sort of stuff. That nobody asks, hey, is there anybody else going to talk? Nope. Okay, I'll go. So everybody can start talking over each other and things get garbled. So there's a maximum amount you can have in an area around a receiver before the planes themselves start screwing with each other. So it doesn't take much to tip that over. So if we look at that's for ADS-B out. That's just plane to air traffic control. What about plane to plane? ADS-B in. So we're now injecting data into the cockpit. You can inject confusing, impossible, scary types of traffic. You could elicit a response. I mean, there's lots of procedures in place to vocally verify with air traffic control if they receive weird orders or anything like that. Yeah, you could say, hey, there's something a half mile away coming straight at you. Your display is going to light up like a Christmas tree, and all these warnings and everything. Are you going to have time to do a verification on that? Particularly if you say it's coming from below you where you can't look. You're going to brown some shorts across the sky here. Conflicting data between air traffic control and the cockpit displays. Combine this with other attacks, and you can really muck it up to where nobody knows what the hell's going on. Or attack both at the same time. Because aircraft have no source for multilateration. They're a single point receiver. Yeah, they might be able to figure out which quadrant a signal's coming from, but they have no way of verifying that the signal coming in is from a location that it says it is. This is a problem. It makes the planes themselves even more vulnerable. All the statements from the FAA and everybody else about any of this research has always focused on injection into air traffic control. They've never spoken about plane-to-plane communication and the possibilities there. So that's always interesting. Yeah, GPS jamming. If your GPS is your data source for locations of the plane, what happens if you jam it? North Korea, along the DMZ between North and South Korea, has been regularly jamming GPS, and makes for an interesting study. Planes don't even dare fly anywhere near that. Around 40 of 63. This could be interesting. UK tests found that there was they set up receiving stations along the highway and found a whole bunch of situations where there was people running GPS jammers up and down the highway. It's a neat case at the Newark Airport in New Jersey. Never go there, by the way. It's a terrible airport. Where there was a GPS was being jammed regularly on like 2 o'clock on a Tuesday every week. They were like, what the hell is going on here? Because it was regularly occurring, they were able to gear up and track it down. It was a truck driver that the truck, his boss had low-jacked with a GPS tracker to make sure that it wasn't going off course or anything like that. He had a cigarette lighter GPS jammer, would plug it in, park in a parking lot that happened to be right at the end of the runway at the airport where one of the receiving stations was, and took a nap. He didn't want his boss to know that he was off, not doing what he was supposed to be doing. Oh, it was in a really long tunnel. But yeah, here's a guy that was just screwing around with a $20 thing from Deal Extreme that jammed a friggin' airport. What happens if you tucked one of these into baggage with a battery and a timer on a plane? Fun. You know, the best things on planes are generally not explosives. So the crap I've gotten through security is nuts. What does this do? This removes the ADS-B advantages, causes delays, confusion. You have to fall back to older modes that generally were problematic before. Now you've increased capacity, and now you've removed the advantages. It's going to get weird. I've had many a pilot tell me that, yeah, generally if we have to go on instruments, start praying, because they're rusty at it. They've got all of this automation, all of these systems, all this information. They don't get a lot of chance to practice straight instrument flight. So they're not even confident in it. GPS spoofing, kind of a new thing. Introduce manipulated data data to the system to say you're not in some place that you actually aren't. Aircraft location isn't reliable anymore. Best of case, fall back to traditional navigation. Worst case, yeah, you now remote steered an aircraft to go to a location that it wasn't supposed to. Iran may have used this. We'll never know the actual things for this, but they captured a U.S. drone, and they figured they spoofed GPS to say, hey, you're back at your home base, and it automatically clicked into automated landing procedure. Team out of University of Texas was able to screw with U.S.-based drones for about $1,000 worth of gear, where it was sitting stationary. They spoofed it, and it suddenly started moving because it thought, oh, I'm not where I'm supposed to be. I'm going to go where GPS says I should be, which was not where it was supposed to be. There's some threats that are total unknowns. We can't anticipate everything. The air traffic control system is huge. Like I said, you saw those videos of how many planes and all the coordination that's got to happen. I don't know if anybody's actually got the whole thing in their head to look at. I'd love to meet the person that does. Has anyone fuzzed a 747 or air traffic control tower? What does a buffer overflow at 36,000 feet look like? And I'm not talking the buffer overflow of people trying to shove bags in the overhead bin like they've been doing lately. Have they been verifying their silicon that they've been putting into these things? Have they been verifying that the code on the chips is actually doing what it's supposed to? Could it be that you send in specific commands and weird stuff happens? It's always concerning to me looking at things like supply chain interdiction. The drones are another cause of concern. They've been integrating autopilots because if you're flying domestically, for border security or whatever, obviously you're having to work in commercial airspace. So they've been integrating ADS-B or ADS-B with the flights, so the drone itself automatically will know, hey, there's a flight coming that's going to cross my flight path. I'm going to adjust my course without human intervention. Think about that. I say, oh, I'm flying along. There's a plane above you. I'm going to go down. To my right, I'm going to go left. I can now remote steer a drone. What happens when a predator-sized drone suddenly ends up in a suburb? A bad day if you're the PR guy for whatever agency had that drone. In the 2013, the sequester, the whole budget crisis in the States, they were threatening to close 173 towers. These were smaller towers at smaller airports, in some of the flyover states and stuff like that. But they were valuable intermediaries between the larger airports. They would take some of the load of handling the traffic from the bigger centers at either end. What this would mean is that those bigger centers would have, they're already overworked. I mean, air traffic controller is like one of the most stressful jobs. It means they're going to be relying more on their technology. They're not going to, it's like, crap, I got to get all this done. I'm not going to do all the necessary verifications I should, humans being what they are. They're going to rely on the technology more. They're just going to trust it. Congress restored the funding. They didn't close those towers, but obviously it's a target that anybody who's budget conscious is going to want to try to close. You'd hope that the engineers that designed this stuff thought of all of this ahead of time, and the DHS and FAA and everybody else looked into these threats. FAA, to their credit, has submitted ADSB, the proposal, to NIST, the National Institute for Science and Technology in the States, for security certification. But the report is very interesting. FAA specifically assessed the vulnerability risk of ADSB broadcast messages being used to target air carrier aircraft. This assessment contains sensitive security information that is controlled, and its content is otherwise protected from public disclosure. We can't tell you what the results were. And it gets worse. While the agency cannot comment on the data in this study, it can confirm for the purposes of responding to comments in this rulemaking that ADSB does not subject an aircraft to any increased risk compared to the risk that is experienced today. What risks are those? I mean, they're saying, it was certified by NIST. Well, certified as what? We can't tell you. Failure is a certification level. Just saying. The threats that they're comparing against, I haven't found a good list of what the current threats they were comparing against. And are you comparing apples and oranges in that case to old stuff that isn't relevant to new stuff that is now possible? They just haven't seemed to think forward as much. And the interesting part with NIST is that this sounds an awful lot like security by obscurity. System security should not depend on the secrecy of the implementation or its components. That's out of the NIST Guide to General Server Security, something that we're all probably familiar with. The idea that, particularly in crypto, where you can know the system the whole way through, it's the key that is the secret that you need. Something about a goose and a gander, that NIST on one hand is saying, we can't tell you, and the other hand saying, that's a bad idea. Multilateration, back to this. My question is, okay, so you've got a system that is doing this verification. How is it indicating a mismatch? As we saw, EASA said at points, yeah, if they cross paths or if there's duplicates, weird stuff happens. How are they dealing with inconsistencies? What is the liability for manufacturers if they throw out known good data, or data they should have? FAA says they've never detected a ghost flight. Maybe no one's actually tried it yet. Maybe they just haven't caught it. Various plane spotters, there's a website, airframes.org, that's cataloged 1,770 oddities, as they call them, which is duplicate numbers. Somebody moves states, doesn't re-register right, or doesn't change their address. That's a lot of weird stuff that's just happening normally. You can hide in that noise if you're malicious. The response has always been just trust us. There's a talk at DEF CON this past summer that was 25-year industry person in the aviation industry and a former airline pilot. Their whole talk was assertions, not evidence. They said, you can't do that. They're not connected. They're not supposed to be connected. Things like that. It was really a weird thing. Because there were a lot of reductio ad absurdum, where they would take some of these attacks and amplify them to ridiculous levels, and you could see, oh, that's not going to work. But nobody's talking about trying to reroute a flight from to Cincinnati to Cuba. Yeah, that's not going to pass muster. But introducing some conflicting data or a different flight approach, could. I'm not trying to spew FUD here. I'm trying to raise awareness and pressure on the industry to get with the program and start working with people like you that are in this room that see things differently and can make things safer. And Hackers Looking at Air Traffic Control has gotten quite an interesting response. Many reports from people of me being cursed at meetings at various places, I've been reading a lot of documents where I'm all but mentioned by name, and it's funny when you find some of the early drafts that they forgot to delete off the sites that are a lot more vicious in their assessments. But I'm not going away. I'm wanting to get full public answers here. Office of the Inspector General has initiated an audit and already found a few interesting things. President in 2013 State of the Union specifically mentioned air traffic as a cybersecurity concern. And many academics, I've just, like in the last month, been handed 2 drafts of final papers to go through. People will say, it's too expensive or too complex. Well, I got a RTL SDR, which I've one of those cheap USB TV tuners here, that's able to read ADS-B, because it's right in the smack in the middle of the frequency range it can do. There's a Hack RF, Blade RF, USRP. What's your budget? You could do bigger and badder things with the more expensive stuff, but it's not a huge cost. It used to be that, to talk to a system like this, you'd need, this $10,000 radio or $100,000 that you can only get from one manufacturer thing. Well, no, with software-defined radio, we can make our own really easily. Obviously, amplifiers, antennas, other stuff like that, but still, your price point is really low. Less than a car. Well, good car as opposed to cars I can usually afford. Interestingly, while I was en route to Poland in flight, thank God for in-flight Wi-Fi, Nick Foster had told me he had implemented ADS-B out in GNU Radio. There's a synthetic message that he had generated of a fake flight. This isn't theory. We can actually do this. We've got the GNU Radio plot to do it. And he raised his game to absolute badass. He integrated ADS-B into Flight Gear, open source flight simulator. This means that he, yes, I know, I'm probably going to go a little long. You can just deal with it. So basically your plane is generating location data and piping it out as if it was broadcasting ADS-B out. And then also at the same time pulling that data in from the real world into the flight simulator, so populating a flight simulator with the real planes. Your flight characteristics in the flight sim are going to be very much like a real plane. So what did he do? He did this. So you're going to see you've got the cockpit view there. Google Maps is basically air traffic view that's pulling in from a real ADS-B data receiver that the out from the flight simulator is connected to, and the data stream at the bottom there. Where am I going? So if we slide this one over. Come on. Stuff never works if you embed it in the thing. So I don't know if I have to watch here. But basically, you've got San Francisco Bay here. Flight Your Mom, which is the synthetic plane being generated here, flying out over the bay. There's real flights in the flight simulator there as well. Unfortunately, never got close to them. But as he was telling me, he's like, right hand was on the mouse, moving Google Maps. Left hand is on the joystick, controlling the flight. Both of which were really hard because he was laughing at himself hysterically because he's turning back and currently aiming towards SFO Airport. And he's going to buzz the tower. So if you're air traffic control and you're seeing a flight loop around like this, you're going to go, what's going on? And, particularly if it's, not Flight Your Mom, and something, real or spoofed, you've only got a few seconds to figure out what's going on. I mean, you may be able to look out the window and see it's not coming out, but when you've got a plane coming at you inverted and buzzing the tower, something's going to happen. And I don't want to be on a flight in that area when that happens. I don't know about you, but it's just not something I want my pilot having to deal with. Oh, crap. There we go. So the capability exists to generate this data. I mean, obviously this is a test environment. We took all sorts of precautions to make sure it didn't actually pollute the air. It was through a cable, changed to 900 megahertz. But this only took him a weekend, and I just had to prod him to do this. We could do this for general aviation too, who won't have the same kind of systems and verifications as commercial flights. We didn't release the code because we're not insane. Also, because I travel across the border a lot, it's like I didn't want that kind of imperial entanglement. However, others did. Sitting on GitHub right now, from a guy out of China, of all places, and things like working ADS-B flight path generators. So you basically say, I want to go from here to here, and it generates a packet stream of you going from A to B at certain speed, altitude, and everything like that. That's a socket source, so you could just output that to whatever the hell you want. All the pieces are there. The exploit is in the wild. And that's scary as hell. Because this is one protocol among many, many. You think the computer industry is bad for alphabet soup of acronyms? These guys are worse. But there's other things like tailored arrival, where air traffic control uploads an unauthenticated, unencrypted flight plan for your eventual crashing, landing. ACARS, Hugo Tessa did some work on this, and there's some other some contention on the effectiveness of his research, but still, it's does anybody think it's a good idea when you've got pilots that make decisions based on data? Do you think it's a good idea for me to be able to introduce any sort of data into the cockpit? Probably not. You read about one system, it leads you to so many others. You could spend your entire life on this. But doing this research and making these presentations has started to make a difference. Found some documents from April of this year, so 2 years after I had first presented this, saying that, hey, maybe we should form a task force a working group to look into this stuff. 2 years, really? Security has been added as a line item in the operations guidance for ADS-B. It wasn't there in previous versions, which is scary in and of itself. They're found some risk assessments they finally have started doing. They're looking into this stuff. But interestingly, none of them have ever contacted me. You'd think it would make sense that not everything fits into a presentation that I might have. You might want to talk to me. Just a phone call's cheap. Looking ahead, ADS-B is going to be mandatory by 2020. So every flight over a certain size, over certain altitudes will have it. They're already overhead. It's being implemented. The aircraft industry is very insular, I've found. That they're like, hey, look at us. We're the masters of physics. We can make crap go through the air and not fall, hopefully. But they're looking at safety engineering. They're looking at redundancy, checks, inclement environments, failure modes, stuff like that. That's safety engineering. That's not security engineering. Security engineering there's an intelligence behind it, and it's data that checks out but is wrong. Things like that. They're not engineering for a lot of that, I find. There's still time to develop countermeasures. Don't turn off primary radar. It's worked for like the last 70 years. Let's keep it up. Train the air traffic controllers on what to do when weird crap happens. Currently, they're not. They're told basically to trust the system entirely. Interestingly, I just found a document about 2 hours ago that in their threat matrix listed everything that I have discussed here. So 2 years ago, when they said, nope, it's impossible, basically that's a tacit admission that I was right. That this stuff, there is problems there, and they are finally addressing them. But they still have problems letting outsiders come in and test these systems. People that aren't part of the aircraft industry that will try stuff they never thought of because we look at the world differently. Side note, if anyone has a 747 and air traffic control tower I can borrow for a weekend, maybe with enough gas to get to Aruba, please let me know. Also, I just discovered that the Air Traffic Controllers Association is having Aviation Cybersecurity Day on the 13th in Arlington. If anyone has, expense accounts and wants to send me, please do, because I think that would be absolutely hilarious for me to show up there and cause a ruckus. That's the sort of event that you'd think that they want me to participate in. Thank you very much. I know I went a little bit over. I owe next couple of speakers some beer, but questions? I'll be down in the lounge. So, there you go. And how many of you are wanting to walk home now?